Morning. I thought you were going straight to those puzzles for some reason.
No, I just need to know what puzzles.
It must have been easy enough if you went straight to it.
Sorry?
I was just saying that there must have been a puzzle or something that was eating away at you if you had to go straight to it.
I know, right? Oh, that piece went there. No, it didn't. I like the name today.
Yeah. I had one in my pre-cal class yesterday that I thought was pretty good. I'm sure you've heard the joke, like, why was 6 scared of...
Why was 6 afraid of 7?
Yeah,
Because
right.
7 ain't 9.
Yeah, but this one was just a different take on it. Can you read that? Let me zoom in.
I can read it, but I don't know if I get it.
You gotta look at this down here too. The calculator part.
Oh. That's pretty good.
Just a little extra twist to it. I'm not sure that any of my pre-cal students caught it though.
Yeah, they're different.
Yeah, I'll explain them.
I started putting oat milk in my coffee. So I was like, well, I'm lactose intolerant, so I probably shouldn't be drinking regular milk every single morning. It's probably bad for me. But I think it's giving me migraines. I'm so serious. It tastes the same though. Brendan, is there maybe going to be another Rocklahoma that I can go to get rid of?
Yeah, next year.
Next year?
Yeah, same thing. September 1st, 2nd, and 3rd.
Definitely hit that up. I think in my heart, I really need one of those shirts. It says Rocklahoma.
You think you're gonna remember in a year from now?
I'm putting it in my calendar right now.
You could maybe just buy one off somebody.
But that's not cool.
Oh, okay.
Like your sweater.
Yeah, just don't go.
How was the fashion show?
It went so well. Our team got third
There was-
place.
There was a lot of.
Out of what, 4?
No, out of funny. Out of like 20. So it was pretty good. Brooke was modeling. You want to see a picture of what it looks like? I'll show
Okay.
you.
Is that why she's not here today? She's too famous?
So she's on dance,
dance.
so she's at state right now. This is ours. The team was Rio.
Okay.
Yeah. You gotta make it out of like unconventional materials, so we just use like tissue paper and wrapping paper.
Oh, so she was part of your team.
Yeah. We won
I
like
see.
$80 worth of gift cards though, so that was pretty good. Nice.
Anytime I win gift cards, it's always to some place I don't go to.
That's funny.
Got bought out.
You're so studious.
AJ. Mart. To Matthew Mason.
Yeah, I guess. Yeah, I have a college visit tomorrow, so I'm missing the last two classes. I don't know, all my tests were this week, so.
Good morning, FHS. Today is finally Friday, November 10th, 2023. Please join me in a minute of silence.
This class. Site. Pretty tough.
Please stand if you are able and join me in the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. Thank you and have a great Friday and a great weekend.
I like the meme today.
Good. I'm glad you like it. Okay, so first off, while I start to give some directions here, I need y'all to get out that number 59 that you picked up after the test yesterday. I'd ask you to do parts A, B, C, and D. And that was so we could move on to part E pretty quickly here. So start digging that out of your binder, please. The handout you picked up by the door is number 60 and 61. So 60 is going to be where we try to graph some function graphs and some second derivative graphs given the first derivative. So we've been looking at first derivative graphs lately and talking about the function, but maybe not drawing the function. So we'll do a few of those together, and I'll have you do a couple. And then the same type of topic I'll have you do in a card sort, which will be 61. So that is also one of the handouts you picked up. The papers that were on your desk, all 4 of those make up 62, which is the curve sketching quiz review. So I don't know. When I put them in the copy machine, I thought I told it front and back and to staple, but then it was out of staples, and then it didn't do front and back. So I didn't want y'all to have to pick up a million papers. So I put those on the table for you. So anyway, it looks like it's more than it really is because this is just one-sided. But okay, so I don't want to spend much time on parts A, B, C, or D, but we do need to know the answers from those, and I am going to have you turn it in, so your work does need to show and reflect. I guess that gives you a chance to go back and fix some of that if it's off. But this second, honestly, all of this should have probably been on the last test. We just spaced it out a little bit. But this is really the same stuff with one new idea mixed in. So, on your FRQ, again, you should still have the work that goes with this. But part A, when do you have a tangent with the horizontal line? You should have ended up with -1, -3. Part B, when did your tangent line have a undefined slope, vertical line? That's at 0, 0. Again, I'm not going through the work. I asked you guys to practice this already. If your answer doesn't match up with these, then you need to go back and retry those for homework. Part C wanted the coordinates of where the absolute max and absolute min occur. There was an absolute max at 8, 24. The max value is 24 at x equals 8, but it asked it as a coordinate. So I'm giving it as a coordinate. And then the absolute min was when x was -1, the minimum value was -3. And then part D, when is this concave down? That would have been from 1/2 to 8. Not to infinity, because we only care about -8 to 8. So again, we've done these topics before. If you miss these, you need to go back and retry them until you come up with that answer. These type of questions will be on your curve sketching quiz as well. But what is new is now part E. E is the actual curve sketching part. It says sketch the graph of this function on this interval. So part E, we want a very accurate graph. So of course this is still no calculator. If we had a calculator, we could just graph it and then copy it to our paper. But you have to realize that all of this stuff before it is leading you up to this. If you know when there's vertical and horizontal lines, that helps you know what your graph looks like. If you know where the absolute max and absolute min occur and what they are, then that helps you graph it. If you know where the function's concave down, like part D, that helps you graph it. So there's lots of stuff in here that we've already done that help us with that. So if we start off with the things that we know, so part A, there should be a horizontal tangent line at -1, -3. So at that instant, the line should be horizontal. At 0, 0, at that instant, the tangent line is vertical. And within finding this absolute max and absolute min, I've got a couple points. I've already got -1, -3 on the graph. So I'm going to cheat a little bit. If that's the lowest point, I just want my graph to go up higher, that's all. That's the absolute min. Absolute max would be at 824. So this would be the least accurate part, but 824 is supposed to be the absolute max. Okay, now within part C, when I was finding this, I did a candidates test. So I tested the critical numbers and the endpoints. So not only did I get those two, but I also had to test -8 and got that it was 8. So let's throw it on the graph. Right there. And also doing this candidates test in addition to 824, -1, -3, in addition to -8, 8, I also ended up with 0, 0, but I guess we already knew that one. Okay, and finally, really the last thing I need here is in part D, I did some concavity stuff. So I had to figure out where it was concave up and concave down so I could say where it was concave down in part D. But it looks like the first section here until x equals 0, it's supposed to be concave up. So I've got a couple points that I know need to be connected, and I know it's supposed to be concave up. And then it's supposed to stay concave up until x is 1/2, and then from 1/2 to 8, it's supposed to be concave down. So try to add some curvature this way. That is a good and accurate graph of f of x. It's not perfect, of course. It's not going to be as good as the calculator, because the calculator just plugs in a million points. But if you know when a graph's going up and down, increasing, decreasing, that helps you know what the shape of your graph looks like. If you know when the graph is concave up and concave down, that helps you know the curvature of your graph. If you find horizontal tangent lines and vertical tangent lines, so I did a pretty bad job here, I should probably go back. This is supposed to be vertical right here for just a second. So maybe more like this. If you take all of those things you've been practicing, put them on a graph, the only other thing you need is to think about specific points. So some of these points we discovered naturally from the candidates test, like this one, and this one, and this one, and this one. But if you felt like you needed more points, of course you can find more points by just plugging in x values into the function, the original function, and solve for y. So that's what curve sketching is. Instead of just individual, when's it increasing, decreasing, or individually, where is it concave up or concave down, or individually, what's the absolute max or absolute min. Curve sketching is where you put all of it together and then maybe find an extra point or two, and you should have a very good idea of what this graph looks like. Okay, so just to show you how close we got, let's go ahead and graph it. Of course, this is a good way to check your work too with curve sketching. Obviously don't get your answers this way, but I only care about -8 to 8, and then based on my work, I think it goes down as far as -3 and up as much as 24. So I'll change my window settings so that it looks the same bounds. So does that look like what we had? Pretty close. Close enough, especially considering that, you know, we may have only spent 20 minutes or 15 minutes on finding these parts. But again, if you can figure out when it's decreasing, when it's increasing, when it's concave up, when it's concave down, a couple points, pulling all of that information into a graph is what's called curve sketching. And that's really the only new thing in the second half of this unit. Okay, so questions. I don't want to go over questions from A, B, C, or D. If you missed any of those, I want you to retry those before you turn it in. But questions about how I pulled that information to come up with the graph. Okay, then let's move on to the next handout, which would be this guy. So again, we're just getting a little bit more practice, maybe looking at these questions in a different way, hoping that something clicks. So let's look at the first couple together, and then I'll have you do the next couple. So notice in each of these rows, only f prime has been graphed for you. So knowing something about f prime, just like we've been doing for weeks, if you know stuff about f prime, you should know stuff about f. And then we're going to do the same thing. If we know some stuff about f prime, we know some stuff about f double prime. So we can get some reasonably decent sketches here of what these look like. Okay, so when the first derivative is positive, what does that tell me about the function? Increasing. So I know the graph's going up from 0 to infinity, and it's going up from negative infinity to negative 2. Now, I don't know the y value that this started at. I don't know the y value that this went to, but I know it's going up during these times. So my function should be increasing during those times. I don't know what they're increasing to, I don't know what they're increasing from, but I know that they're increasing. Okay, and then when the first derivative is negative, what does that tell us about the function? So can I just connect these now? No, I probably need to adjust this a little bit. I know it's supposed to be decreasing from negative 2 to 0. So let me adjust that first little part. Now it's increasing during the right time and decreasing during the right time. And I try to have that color coordinated to help you see. Again, there's nothing special about this y value or this y value. I just have to pick something. Okay, well, we can do a little bit better than that, because not only does the first derivative help us know when the function's increasing or decreasing, it should also help us with concavity. When the first derivative is increasing, that means the second derivative is what? The second derivative is not concave up. Second derivative is positive, which means the function is concave up. You just have to be careful that we're talking about the same thing. So this guy should be concave up from negative 1 to infinity. So right here, instead of having these be sharp edges here, I should add a little bit of curvature so that it's concave up, but not mess up the increasing, decreasing. And then for the same thought process over here, when f prime is decreasing, that means the second derivative is negative. And when the second derivative is negative, it's concave down. So instead of making this so sharp here, we'll just add a little bit of curvature. And that's a reasonable guess for f. Again, the only thing I really don't know is this guy's y value and this guy's y value. But There's not enough information for us to know that, so we just have to leave that as is. Okay, so let's have you practice this in the next row in 2 steps here. So first, just worry about increasing, decreasing. Look at this. Think about when is your function increasing and when is your function decreasing. And then just try to make with the sharp lines where it's increasing at the right times and decreasing at the right times. And then we'll check that, and then we'll come back and talk about the concavity part. Okay, hopefully that's long enough here for this first part. When the first derivative is positive, your function should be increasing. It should be going up from 2 to infinity, and it should be going up from -3 to -1. It's going up during those 2 times. I have no idea how accurate that is yet. When the first derivative is negative, your function is supposed to be decreasing. So it's going down from -infinity to -3, and then it's supposed to be going down from -1 to 2. So let me make this go down from -1 to 2, and then maybe I'll switch this up a little bit. So my exact picture does not have to look exactly like yours either, but it does have to be increasing during the right times and decreasing during the right times. Are we okay with that? Okay, now of course this is probably not what the function looks like. Actually, we know this is not what the function looks like. How do I know for sure this is not what the function looks like? Okay, so concavity aside, what's another way to know that this could not be exactly the right function? Okay, that too. I was thinking, what, can I take the derivative right here? Because that's a cusp. So, right, if at -3 my function shows I can't take the derivative, then at -3 the function shouldn't exist, and it looks like the function, or the derivative is 0. So, those sharp turns are definitely not allowed, because it's saying no derivative exists, but the derivative exists right there. We can see it. So, okay, so take a second and then try to add some curvature to it. Add the correct curvature. Think about concave up versus concave down. And then update your first derivative. Okay, so again, I'm not going to write out all the things here, but if you know when the first derivative is increasing, that's when the second derivative is positive, which is when you have concave up. So we need to make this look like it's concave up from 1 to infinity without messing up the increasing, decreasing stuff. And it needs to be concave up from -infinity to -2. So same thing. Add the curvature without messing up the increasing, decreasing intervals. And then it's supposed to be concave down in between because f prime is decreasing. So try to add some curvature there that does not mess up the increasing, decreasing intervals. That is one acceptable answer. Again, this y value, and this y value are just completely guessed. We don't have enough information to know those. So your y values there could be different as long as it's increasing at the right times and the right concavity at the right times, then that's as accurate as it's going to get. Are we okay with this, or do you have a question? Okay, then let's go back to the first one and let's talk about the second derivative. So we've really put some thought into this already, right here. When the first derivative is increasing, the second derivative is positive. So from -1 to infinity, the second derivative is supposed to be positive, which means above the x-axis for him. And when f prime is decreasing, the second derivative is negative. So on the second derivative graph, negative would mean below the x-axis. Second derivative is negative, concave up if you're talking about the function. Second derivative is negative, means below the x-axis if you're talking about the second derivative. And that's all we can do. Okay, let's do that one more time here. And then I want to point out one more connection that I think can help, and then I will have you try the entire third row on your own. So when the first derivative is positive, or when the first derivative is increasing, the second derivative is positive. So this should be positive until -2, and positive from 2 to infinity. Positive means above the x-axis. When the first derivative is decreasing, second derivative is negative, and negative means below the x-axis. So, I don't know. Do I do it like that?
Can you just make it look like a parabola? I mean, does that not work?
Right, yeah. You need these to connect. I'm just making sure that makes sense. And then, I don't know, this is kind of funny looking. Personally, I would probably, you know, make it look a little bit more like what it probably would look like without messing up the other stuff. Okay, the one other connection I want to make here is a lot of times when we work with derivatives, sometimes it's with tables, sometimes it's with piecewise functions. More often than that, it's a graph, and even more often than that, it's a function. But if you think about when you have a function, if it's like a third degree, then his derivative would be what? Okay, a second degree. I'm not worried about exact derivative, just if the function is a third degree, if you did power rule, it becomes a second degree. If you took the derivative of the derivative and you did power rule again, that's going to give us
First.
something linear. So notice how this, the function, looks like maybe a third degree. It's got 2 turning points. Based on the power rule, it's going to lower the power by 1, so his derivative, looking like a parabola, makes sense. And then the derivative of that should be something linear, which matches up with this, which makes sense, it's linear. Whereas this looks like it's probably like a 4th degree, because it has 3 turning points. So his derivative would have 1 less turning point, like a 3rd degree, and his derivative would have 1 less turning point, like a 2nd degree parabola. Can you see how the degrees just get knocked down by 1, just like the power rules knock them down by 1? So sometimes that helps you kind of organize. The equation should get simpler the more times you take the derivative. In fact, we don't really do third derivative, but do you know how you could do a third derivative graph on these?
Just like where the second derivative graph is increasing and the third derivative is positive.
Well, where is it increasing?
to infinity on the second one.
Okay, what about the first one?
Oh. Well, it would just be a
It's always increasing, right?
horizontal line.
Something positive, right?
Yeah.
Yeah, so whatever that slope would be, that's roughly what the third derivative would look like. This one would have to be, this is like a parabola, so his derivative would look linear, right? You'd have to put some thought into exactly what it looks like. Okay, I'd like you to try this entire next row. So feel free to jump back and forth between function and second derivative. Feel free to do second derivative first if it seems easier to you, but you need to see how that goes and if it sticks or not. And of course, if there's something you're not naturally thinking of, you should probably write it out in words at the top of your page so you can quickly review it later. And I'm going to try to be patient here and wait a few minutes so everyone has time. If you're feeling confident, go ahead and move on and do the last one too. I'm going to ask everyone to do that anyway, so. Okay, I'm going to assume you're either finished with this row or slowing down because you're getting stuck. So let's check and make sure this is correct. The last one, I will come around and check each paper individually before you move on. So when the first derivative is positive, your function should be increasing. So your graph should be going up from -1 to 2. During those times, it's the best we can do. And then when the first derivative is negative, the function is decreasing. So just thinking about when the first derivative is positive or negative gets you to something like that. Again, this y value and this y value totally don't matter. What matters is that it's increasing and decreasing at the right times. Okay, and then concavity. When first derivative is increasing, second derivative is positive, which is concave up. So it should be concave up until about x equals 1/2. So try to make that concave up there without messing up the increasing decreasing intervals. And then when the first derivative is decreasing, the second derivative is negative. When the second derivative is negative, it's concave down. So same general shape, but we just need to add some curvature to it without messing up the increasing, decreasing intervals. So something along that shape. Again, the y values here and here don't matter. We don't have enough information. Okay, and then I've really kind of already put in this dot as well, thinking about when this increases or decreases, but I need to put it on a graph. When the first derivative is increasing, the second derivative is positive. So it should be positive till x is, it's about 1/2. And then when the first derivative is decreasing, the second derivative is negative. So a second derivative graph, negative means below the x-axis. Okay, any questions about that row? Okay, I'd like you to do the last row, please. And I will come around and give you the thumbs up or give you some feedback if I disagree. And then the other handout you picked up by the door is a card sort. So you can fill in the top part of that while you wait for me to get the cards out of everybody. So I'll give directions here in a few minutes. All right, let me check your bottom row when you're finished. And yeah, that looks good. And then just start filling this out. Those look good. So let's start on this part. Okay, I agree with this one, I'm not sure about that. Yeah, see right here, the first derivative is positive till 6, so your graph should be going up until 6. You've got it going down here, so that part doesn't match up. Okay. Get that. Start filling this out while you wait for directions on that. Go ahead and start on this part. Think those look good?
Huh?
So go ahead and start filling that out while you. Okay, that works. Yep. I mean, I kind of doubt this one does this.
Yeah.
Just it's probably more like a regular Bravo, but yeah, based on the information, you don't really know either way. Okay, that looks good. Did you fill out this top part?
Do you want to just arrange them in order of like how many, like what different questions?
We figured out what to do there. Okay.
Thank you. I don't know if that's helpful at all. This is the first draft. So it's, I mean, this is the.
That one.
Like that has to be. This is 30. Yeah.
That one looks fine, but there's probably some curvature there.
So it's.
I don't know that 100% sure, but probably.
Can you basically just assume there's curvature if you have like a
Okay.
plus and then you so.
Curvature if you have like a.
Like, no, I'm talking about, she said you can't take the derivative and there's like a short term. So then you can just assume that there's like here and then see it for one there.
If the function does this,
Like in
the derivative can't exist here. So either the derivative is going to have like a hole, so it doesn't exist, or it's
So the same derivative would be.
vertical, so it doesn't exist.
I think this one's gotta be a function.
Okay, this looks fine, but you need to add some curvature to it though. And on this one,
So then the floating
where this is going down, it's
A negative two, a negative two,
when it's
zero.
increasing,
Is that-
it's above the x-axis.
Same
When
as
it's
zero.
decreasing, it's below the x-axis. So you should end up with a problem.
Thank you.
And I also put this
And then start filling this in.
one. Is this one anywhere from decreasing following?
I mean, which one? Oh, yes.
Okay, if you need more time on that, that's fine, but I still would like to visually confirm, just in case something's off, that you give some feedback. But let me give some directions on the card sort. So the card sort is this page that you picked up by the door. So the top part is for you to fill in like what you know about when it's increasing or decreasing or concave up, concave down. So if there's any of those you're not sure what it's asking for, you should work in your group, and if your group doesn't know, then ask me and I'll help you fill it out. But then you've got a bunch of cards, and what makes this one tough is they're not colored or anything. So some of those cards are functions, some of them are first derivatives, and some of them are second derivatives. You have to try to figure out, basically just like what we did here. If I cut those out as different graphs, you would have to figure out that this is the derivative to this function, and this would be the second derivative to this function. You got to see which ones go together. So, how the degree goes down as you take the derivative gives you some hints. The second derivative usually has or does have a smaller degree, it's usually linear or maybe quadratic. Whereas the function has not had its degree reduced, so it's gonna have a much higher degree, much more turning points. So everything, there's no tricks to it, everything matches up exactly perfectly once. And each card has a number on it. So those numbers are what you put in the box on the bottom of this page. So those you can work in as a group, help each other out. And I would like to check those as well.
That's how we like this.
There are now,
So it should be decreasing. So it should go like this way. None of them are like -2.
Pardon? No.
So it's gonna start out
Pick one of these and I'll flip it. Or pick one of these.
I was confused because it's like, this is a negative slope, but it's above the x-axis. Well, it's negative. Yeah.
These are 3. That's a 4, right?
No, it should be increasing. Yeah, so increasing from 0 to -6.
So,
15. The lowest one is 6. What are we saying? This is the first derivative.
Okay.
yeah.
And this is the function. And the
So,
function's the
it's
one.
easier to go from function to.
So increasing. So that's increasing. And then it should start to decrease. So it's decreasing until negative. It's decreasing until 1. And then
Okay. So say this is, which one do you start with? So say this is increasing from 1
so this one should go with this
to
one, right?
infinity.
It should be a lot.
This is it. So those go together.
Okay.
Mixed up.
So this increases from wait.
Negative.
How does that even make sense? It's not really.
We're thinking of it right, so like, it's decreasing.
But this is the slope of this, right?
Below
Basically.
axis.
So
Mr. Johnson, me and Frankie have a
this is
question.
like 4 and
Oh, no, it's positive. It's above the
they
x-axis.
match.
This is horrible. It's like, and then it's negative 1.
Yeah.
It's negative 1.
Okay, so we think we match these two. But then
Yeah.
I think it's.
This is increasing. Do that.
Yeah.
Okay.
The second derivative can be a parabola too.
Okay, so this one could
I
be.
mean, you got
Oh, wait, I think
5
there's
sets there. So those 3 might be second derivatives, but you've got 2 more second derivatives too.
So would we have two parabolas back to back?
Mm-hmm.
That one's just gonna be a wider.
But I'm saying 2 of those parabolas might be second derivatives.
In the zero.
Okay, then turn them up.
Did you just say
But
parabola?
then you can use not everything.
So it can't be right.
Okay, then move on to one you feel safer about. You've also
So
got
then this one has the x-axis at
Let's do it
negative
again.
positive, so that means it changes. Positive.
But we won't have two parabolas back to back.
So 12, 3,
What I'm
7.
doing is I'm saying this has a slope of 0 and 2. So 2 is going to become right.
So,
So then you slope of 0 is like 0.5. So 0.5 is 0.
this one would be.
Alright, also one more little tip for you guys that I think might help. In addition to thinking about increasing, decreasing, concave up, concave down, you can also think about like horizontal
This
tangent
one
lines.
should look like.
when the first derivative is 0, you should have
Yeah.
horizontal tangent lines.
This one.
Or vice versa. If you know there's horizontal tangent lines at -2 and 0, then the first derivative should be 0 at -2 and 0.
So sometimes think about that, it helps you get a couple points also.
Like, yeah, but those still increasing. So it should be this, one of the parabolas should be above the x-axis, this until -1. And you know that's not right.
Yeah.
So that one would be right.
So it's that third.
And then.
No.
How's it going?
I think that's
Okay. Alright, let me know when you think you have them all and I'll check on the second one.
No,
So
so
we
next
must have one.
That's it.
Oh, we're getting close. Let me know when it comes
So,
to.
So this one is negative.
so this is good.
So there should be 5 of these, so these 3 are probably going to be second derivatives, right?
Right, so that would be.
Probably going to have at least 2 of the parabolas.
So now one of these, it has to be the first.
Wait. Yeah, it is.
So now it's increasing.
And then it's positive, negative.
Put that like over there.
Obviously, if you'll get hard stuff, call me over so I can help you
This can match this.
consider something.
So I really think that's.
So it's decreasing below the x-axis from, it's increasing from 0.
9, 12.
Yeah. Yeah.
So we just need to measure.
Oh wait, let's go like that. So then, yeah, that sounds good. Yep. So
Well.
Yeah, no. Yeah, this one.
Oh, yeah.
I disagree with these shores with
And then down.
Very three shores. But the other 3 are fine. Are you waiting?
Maybe it's the.
This one's 0 right here. Yeah.
That's 0, 1, yeah. And these all have the same set.
I think this one's for sure right.
Yeah. And so it's just gotta be these ones.
Yeah.
I'm pretty sure that's not.
Yeah.
So 12, 13.
Wait, we're
I was like, wait a second.
So missing a card.
Increasing, so above the x-axis, negative to negative. Oh, wait.
Oh.
I agree with this group. You have to put these in your box.
Yeah, this one's good. So these should all match.
Oh wait, no, two.
Two.
And then above from two.
I just realized that like yesterday's test.
Yeah, I feel like this will make it hard
I was like, oh, it's different. That should be a line.
Yeah, we were.
You don't just so many need to. I just
Whenever I feel confident after test, I feel so. Like the last one, I thought I felt
That would make sense with this one though.
So you guys probably.
Unless this is.
No, I'm realizing, I know one of the multiple choice.
Unless we
Shuffle
think
them
this
up
one.
for me before you re-flip them. And then one way for everybody else, you can move on.
Then I walked past and I was like, dang it, that wasn't him. And then I tried to use my justification. So just keep those together and just throughout the line.
I disagree with this group. This group looks good. You need to make sure you put on your paper there.
I feel like we should try this. Let's try this one.
These look good.
I did. I got nervous because nobody else finished.
Below the x-axis until -1. Above the
Get something
x-axis.
different on this one.
Mr. Reed needs to put in my friggin' lab graphs.
Something different on this one.
Then
I retread these three, but you can put those two out of the way. Might just be.
Oh, yeah.
That's the only one that's in.
What two did you change?
Oh wait, the add up to.
Try one more time, and then we'll look at it together.
Another half to one. Yeah.
Here's something mixed up.
And then.
We're thinking about it, right? I know.
So scramble them up a little bit, refill them for me, and then you can move on to the review. I'll wait for everybody else. That's the whole process. Scramble these. Okay, scramble these.
Below the x-axis, that's after the x-axis. Two. So below the x-axis until a half.
Yeah, I'm not. No.
Okay, so one of those has to go with here, so.
I'll give these back
Okay, this has to.
Yes,
thank you.
What is that?
Okay, so decreasing.
So these are both from. This one, oh, that was big. Oh, is that it?
And this,
Do they work together?
below the
Sounds good to me.
Below the x-axis until 3. Yeah, and then above the x-axis.
Alright, are we sure?
Let's see it now.
Yes, absolutely. No questions.
I really hope so.
3 to 2.
Why is 12 here and 12 there?
That's 2, sorry, I erased that.
Okay, that works.
Okay.
Okay, scramble those up.
fix the whole thing, and
Yeah,
then
but not.
start on the review while you wait for everybody else.
Can you check ours?
Remember this was
Figure out how to. Like I was gonna ribbon it and then I just stopped.
Yeah, so I didn't do it.
Agree with all except for these two rows. But these you need to write down in the box.
Okay. So just the two.
So, on with. Those are fine, these don't.
We have 18, 6, 14.
How about your stapler?
Yeah.
Cool.
Like,
Yeah,
okay.
18, 6, 14.
Yeah.
Yes.
18.
Close
I
or.
think that's a 15. Oh yeah, my bad.
15, 6, 14.
Good job, Dave.
And then.
Y'all have them all right?
You almost like if I X to the negative 2/3.
4, 5,
Just so I get the denominator. Yeah, just X.
When does that do?
But you have these. Here.
But I think we started it.
Make sure you look your chart, update it correctly. Scramble all of these together for me, reflip them, and start looking at them.
I think the thing is, yeah.
Well, that's much.
Just for those, you need to put that in five numbers. And then let's get this
Do you know what we had?
I'll tell you that this is actually supposed to be the
They
first.
both did it 0.
These two go together, so that's fine.
Like they're literally the same.
There's this,
Maybe?
also.
I feel like this one was.
I agree, because this is like that.
Let's go with that.
incredibly long. And the one that goes back like this.
That's supposed to be second derivative. You just didn't have the correct. That's supposed to be the function, that's supposed to be the function. This is supposed to be the first derivative. This is supposed to be second derivative, but not correct. These two together. So, we're trying to piece those together now. Okay, and, okay.
So these are basically like the same where they hit. Is it just because this one's wider, so this one's?
Well, like, look at x equals 2. If you had to estimate its slope with rise over run versus this guy's x equals 2 rise over run, which one's bigger?
This one
So that means that this one should be
steeper.
not steeper, higher up.
Higher up. Okay.
Yeah.
Okay.
So yeah, just the steepness of this tells you the values of that. So if this is steeper, higher value is quicker. But yeah, you have to really kind of focus because they're very close. Okay, scramble all these up, please, reclip them, and then move on to the review. Just- Made some changes. Okay, I agree this is a function, but I don't agree that this goes with this. In fact, I'll tell you, this one's also supposed to be a function, so we'll set that aside. And then these three are fine, so add that to your boxes. And then get them out of the way.
tell you that these two go together, but this one doesn't go with it. So think about it. You're close. A little bit. This row is correct now. That row is correct now. That's good.
Let's just make the board.
So just work on the 2 questions from review like this. Okay, that row is now good. That row is not good. Okay, so you got it sorted out. Make sure you need to fill that in too. Okay, scramble those up, re-clip them for me, and then start on the review. Very similar. You can see like when they're increasing and stuff, but you need to make sure that you can distinguish the difference there, because there's a small difference. And update your paper, scramble them, re-clip them, and then you can look at the test review.
I'm like struggling to take the picture of this, like is this like from the homework last night?
Okay.
How do I, like, when I'm doing this, do I move the 2 down like the x to 1/3 or like?
Because 2 is not to the negative 1/3, only x is to the negative 1/3.
I don't know why I keep on like, getting some crazy numbers.
Well, you still need a denominator. No, I think
I
you're.
know, I have the denominator.
I think I had the same thing. I don't think that what you're doing there is wrong.
Let's go and then move that down.
Now see, I just moved it down to its own little denominator,
Mhm.
because it
You can't move this to this denominator because this doesn't have that as a denominator. But you can make it have its own little denominator. And then now it's a complex fraction. You got a smaller fraction within the bigger fraction. So I just multiplied every term by x to the 1/3, and that's actually bigger than that.
What's your pencil? It is to remove the extra 2/3. I just raise it to the 3 part.
Yep.
Okay.
Because if this was to the 1/3, you'd want to cube both sides.
Right.
And if it was squared, you'd want to square root both sides. So you need to do both. What you're saying is correct.
Well, unfortunately.
That prime is changing from increasing to decreasing.
So did you have 1/9 on the 12x?
I had,
Well, I think it's a negative one.
that's what mine looks like.
If I multiply this by x to the 1/3, what am I multiplying? It's like, is it a
Well, x to the 2/3 times x to the 1/3 would just be x to
Oh,
the
you
3/3.
just add them?
When you multiply things with the same base, you add the exponents. Just like you do it all the time. I know you've heard me say this before, but x times x is x squared because you're multiplying things with the same base, so you add the x. And that's where it sounds like that would be really messy, but it actually simplifies it a lot. So. Okay, does anybody still have any of the matching cards out that I did not pick up? Okay. All right, we still have about 20 minutes of class, so let me give a verbal reminder again. The one thing you need to turn in between now and next Tuesday is the number 59. That was the FRQ that I asked you to do before class. I shared my answers for parts A, B, C, and D at the start of class. And if you missed some of those, you need to go back and retry those parts. But those need to go into Google Classroom, please. And you should probably work a little bit on the test review. So I don't have a specific amount that you should get to, but in these last 20 minutes, if I was you, I would probably pick and choose the ones that look the hardest. So if you need some help, I can come around and help. And we will have all of next class to look at the review and work on the review and get questions answered from the review. But again, it's probably too much to do in one class period. So if you get all your questions answered, you need to get enough done that you can come to class next time with the questions ready to go and have enough of it knocked out that you can finish it up and ask the other questions you need to ask if you have other questions. So this is a B week, next week is an A week, so we'll have Tuesday, full class on Tuesday to look at that review. And then the curve sketching quiz is Thursday.
Is that what you
Okay, well right here, I agree. But here, when you multiply this by x to the 1/3, the whole point of multiplying all of these by x to the 1/3 is you want this to cancel. Times divide. So those just cancel, and then those shouldn't change at all.
So why would this one not change?
Well, it's all being multiplied. So timesing by this and dividing by this, these two just cancel out and just leave you an 8x and a +4. Or +8.
So,
And when I say +8,
you don't even need
times is negative, so it's actually a -8.
I know, I just realized.
I think that's the test. No, you just plug in the points. So there's the only points that are
Saturday
needed.
interview meeting on Wednesday, so I can come on Tuesday and then the class I have after is just like the school store, so I could just finish the test.
Yeah, yeah.
Like, my teacher would be fine with me just staying until I finish, like, both sections, or I could come on
I
Thursday.
have lunch, I can't stay the whole time.
Okay, then I can come on Thursday in advisory.
Okay. One of the days will be pretty light.
During class.
I mean, the test. The
Oh,
test is in
okay.
2 parts, but it's like kind of lopsided. One's a little bit bigger and one's a little bit smaller half.
Okay.
I can't divide it perfectly in half.
Okay.
So,
I'll do the more, like, harder one on Tuesday, the longer portion. Is it like split up with FRQs and then multiple choice?
yes.
Okay.
Why is there so much school business today?
Dance state.
Well,
Who else
I'm
has
looking
it?
at my 4th period and it's 3 boys, so I kind of doubt.
I don't know.
There's a robotics tournament tomorrow. Maybe just prepping for that.
Who is it?
It takes a whole day to prep for that.
Who are the people?
I don't know if you know them. Garrett Harper, Wesley Schaefer, Alan Lopez.
Something
Oh, maybe.
Hmm?
something cross country.
Are they cross country?
Because I know Coach Trice is going today too. I know Wesley is.
Marsh?
Didn't you say
Yeah,
Wesley?
yeah.
Wesley Schaefer.
Oh.
Do you guys want to take
I don't know Wesley Marsh.
I can tell them apart and then choose my classes.
Kids a little bit.